Good morning. My name is M. NARASIMHARAO, lecturer in physics. Today I am explaining about the neutral point in the case of two unlike point charges, two opposite point charges. Let us consider Q1 represents the positive point charge placed at the point A. Q2 represents the negative point charge placed at the point B. Q1 and Q2, these 2 point charges are separated by some distance. Maybe 100 centimeter distance, maybe 80 centimeter distance, maybe 20 centimeter distance. The distance of separation is D. D is the distance between these 2 point charges. Where we are getting the null point or neutral point. Suppose I am assuming, suppose this is the neutral point. This is the neutral point. I am calling it as C. At this point, we are assuming we are getting neutral point. Whether it is true or false, we will check. Point C, you have to assume there is a positive test charge here. Positive test charge here. Q naught represents the positive test charge. Test charge means the magnitude of charge is very, very small. It does not affect the existing electric field. Now please, this Q1 charge is positive. Q naught test charge is positive. In between these 2 positive charges, there exists a electrostatic repulsion. The first charge applies repulsive force on this test charge along AC direction. This is the force applied by the first charge on this test charge along AC direction. Now, let us consider at the point B there is a negative point charge. It is a negative point charge. It is at the point C. Q naught represents the positive test charge. In between negative charge and positive charge, there exists a electrostatic attraction. This negative charge is attracting the positive test charge. This negative charge is attracting this positive charge with some electrostatic force. That force I am calling it as F2. At this point C, where we are assuming null point, there are 2 forces are acting. One force is acting due to the in between Q1 and Q0 along AC direction. Another electrostatic force is acting between the minus Q2 and Q0 along the CB direction. At this point, on this positive test charge, there are 2 electrostatic forces are acting along the same direction. Along the same direction, F1, F2 are acting along the same direction. Along the same direction. Along the same direction means what? F1 and F2 are parallel. electrostatic force F1 and F2 are parallel. Both are acting along same direction. These two forces are parallel to each other. These two electrostatic forces are not cancelled at this point. The reason is both the forces are along the same direction. Now both the electrostatic forces are along the same direction and both are parallel to each other and they are in the same direction. These two forces are not cancelled each other. Now F1 electrostatic force, F2 are not cancelled at the point C. Hence, we will not get the null point at the point C or here or here. The reason is F1 and F2 are the electrostatic forces. Due to the Q1 and Q2 both are in same direction, we will not get the null point in between these 2 point charges. Now, we will check. Outside of the charge Q1 we are getting our. Let us assume the null point is outside of the point charge Q1 and outside of the point charge Q2. Suppose P is the null point which is at a distance of x from the first positive point charge. X is the distance between the charge Q1 and the null point. Suppose at this point we are getting null point or not, we will check. Now, here, let us assume at this point there is a positive test charge. Let us assume at the point P there is a positive test charge. On this test charge, this charge Q1 applies electrostatic repulsive force. This charge is Q1. This test charge is positive. This charge is a positive charge. This charge is a positive. In between these two positive charges, there exists a repulsive force. The charge Q1 applies a repulsive force on the test charge along AP direction. This is the electrostatic repulsive force applied by the positive charge Q1 on the test charge. Now, here at the point B, there is a negative point charge. This is a negative point charge. At this point, it is the positive test charge. One charge is a negative, another charge is a positive. These two are unlike charges. This negative, in between the two unlike charges, there exists a attractive force. This negative charge is attracting the positive charge with some electrostatic force along PB direction. This negative charge is attracting this test charge with some electrostatic force of attraction along PB direction. Now please listen here. At this point, at the null point P, first charge is applying the repulsive force along AP direction. Second charge is applying attractive force along PB direction. At this point, there are two electrostatic forces are acting in opposite direction. Traction. Now at this point P, there are four electrostatic forces are acting. One is along AP direction, another one is along PB direction. Suppose if the magnitude of F1 and F2 both are equal, then resultant force at this point is 0. This point we are calling as a null point. Null point means at this point resultant electrostatic force is equal to 0. Force between Q1 and Q0 is equal to force between Q2 and Q0. If magnitude of F1 and F2 are equal at this point, we are getting null point at the point P. Magnitude of at the point P, nothing but we are calling as a null point. F magnitude of F1 is equal to magnitude of F2. Here F1 is acting along AP direction, F2 is acting along PA direction. Both are equal in magnitude. At this point, opposite in direction, they will cancel each other. Resultant force at the point P is 0. Now I am applying the Coulomb's law in electrostatic between these 2 point charges. F1 means electrostatic force between the charges Q1 and Q0. In between the Q1 and Q0, there exists a repulsive force. According to Coulomb's law, 1 by 4 pi epsilon naught Q1 Q0 by distance between these 2 charges is x square. Now is equal to force between electrostatic force between Q2 and Q0. Now please listen here. I am applying the Coulomb's law in electrostatic. 1 by 4 pi epsilon naught into Q2 Q0 by distance between these 2 charges. Distance between these 2 charges is d plus x. Square, I am writing square. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught cancelled, Q0 cancelled. Now please listen here. D Q1 by x square is equal to Q2 by d plus x whole square. D plus x whole square comes to numerator, Q1 comes to denominator. D plus x whole square comes to numerator. D plus x whole square comes to numerator by x square, that is equal to Q2 by Q1. Now this can be written as d plus x whole square by x square. This can be written as d plus x by x whole square, that is equal to Q2 by Q1. If you eliminate the square here, we are getting root. D plus x by x is equal to under root of Q2 by Q1. This can be written as d by x plus x by x. X by x means 1. That is equal to under root of Q2 by Q1. It plus 1 comes to this side, minus 1. D by x is equal to under root of Q2 by Q1. Plus 1 comes to this side, minus 1. Now please listen here. X goes to numerator, this total term comes to denominator. D by this total term comes to denominator, Q2 by Q1 minus 1, that is equal to x. X means distance of null point. X means distance of null point. Distance of null point from charge Q1. X is the distance of null point from the charge Q1. x is equal to d by under root of q2 by q1 minus 1.